Welcome back, everyone. Welcome back to Tech Talks. Our next presenter is Dr. Régin Munger. He's the CEO and founder of Ocular Mobile. His topic this morning, we had a chat before he presented, and it's pretty fascinating stuff. It will be on a launch of an eye screener for mining, which basically helps detect cognitive deficits. So without further ado, Régin.
Thank you. Hello, everyone. I also have here with me our VP Communications, so if anybody in the crowd wants to go chat about our product, she'll be very happy to talk to you. And Peter Campbell, our VP Commercialization, his email is there, would be happy to have a contact from you guys anytime. So we're really excited with this technology that we developed that we think has a broad range of application. And one of the ones that we are intending on trying to use it for is mining. So let me, without further ado, introduce what we're doing. So what is the problem? Workers with reduced faculties, right, are increased safety risk in the workplace. They don't pay attention as much. The reaction times are slowed down. Because of fatigue, they also go into fog. So we need to identify these people before they get in the workplace. And right now, there's no tools available to evaluate cognitive performance. Tools like drug testing and all that only tell you if the person has imbibed alcohol or drugs. But as we all know, some people can have 3 glasses of wine and drive home very safely, and other people can have one and it doesn't work. They're in trouble. So you really need to measure cognitive performance if you really want to know if someone is creating risk in the workplace. So what's needed? A tool that can actually measure and report cognitive performance data so that a supervisor or a company can assess whether this person should be kept off the workplace for a short time. So what is our approach? Our approach is actually fairly simple, and it's been around for many, many years. It's using the eyes as a window to your brain. So I'll show you the kind of things that we measure. If you look here on the left-hand screen, the dark screen, when I start, will show 2 fairly large white dots, which are pupils that are illuminated for a patient. And these eyes are going to be moving all over the place, and we can show you in real time down here, the left and right eye, their performance. So we can measure eye positions 100 times per second, and eye changes in eye pupil 100 times per second. So eye movements and brain functions have been known for decades to have high correlation. Researchers have been using these visual tasks for decades to test the performance. The problem was they're making one-off systems that are expensive, not portable, and not usable in industry. So we have decided to start by trying to detect attention deficits, response speed loss, and decision making. So we're going to specifically target those types of cognitive deficits. And the advantage of that is that all 3 are known to be affected by drugs, alcohol, and fatigue, which are the main conditions that affect industry in general. So what's it? So if you want to test for your fit-for-duty workers, what does a test incur? Well, you can't just do one simple measurement of an eye and figure out the cognitive ability. It's got to be built with multiple tests, and each test creating multiple variables that you can use to assess cognitive function. The other advantage that we have is that technology has moved so much in the last 10 years that we've been able to move a lot of the technology that was in the labs into a product that's going to be feasible for industry to use. The speed of computers, the way we present stimuli to the eye, the ability to record with these cameras, and especially in the near IR. So, and we are including some proprietary implementation of tests that are performed by law enforcement, already validated by law enforcement. So that really lowers the barrier for introduction. So the prototype that we have here, right behind me, has 2 full tests implemented. The first one is, both of them are things that you would have seen before at your doctor's office. The flashing light, where they flash the light and see if your pupil responds. Shrinks or recovers perfectly, and smooth pursuit. The standard tests follow the finger, right? What we're going to do is, instead of being able to measure 1 or 2 things for each of these tests, we will show you that you can now have multiple variables, each one correlated with problems. So here's the first test as we implemented. This here is not actually part of the image. These are what the subject sees in a screen that's being projected to them. Then you have an image of the user and monitoring of their pupil size and position. And right here, you'll have a plot of the flow over time. So left eye had a bright shot of light. The pupil constricted. Now it's recovering. Now I'm going to do the same thing with the right eye, the other eye. And then I'm going to stimulate both eyes at the same time. So now you have a series of measurements. By going from left eye to right eye, you're looking at the communication of the 2 eyes through the brain, and with the 2 pupils to see if the 2 can react simultaneously. So what kind of data can we measure? The purple lines here are when we turn the light on at the different portions on test. So the first thing you notice is how much shrinkage there is or constriction there is in the pupil. That's an important one. You should, if you're normal, you should get at least 50% constriction. Second, you'll notice if you have a digital data, which is hard to see with human perception, there is actually about a 1/4 to 1/3 of a second delay between the light coming on and the eye actually starting to react. That's important. Third, how long did it take me to reach my minimum size? Again, all correlated with impairment. And how long does it take me to recover and get back to having a full pupil? All of these are important because if you're working under conditions where light changes, you're driving, you're operating the equipment, that can make a big difference for your visibility. So if you look at these variables, ambient and bright pupils being when they're at their minimum. If the pupils are very large or very small, that's an indication of either drug use, extra fatigue, or heavy use of alcohol. If the amplitude, the shrinkage that you get suddenly is reduced when you're affected. Latency, which is the delay, increases, constriction time increases, and recovery time increases. So the advantage there is that with all these variables, if one of them's off but all the others are okay, you can say, okay, that's just a one-time test problem, right? So it really increases your accuracy and your validity of the tests. The second test that we did, which is the pursuit test. Again, above here, you'll see what the subject sees as a target, and this will be a sine wave motion this way, and then a sine wave motion vertically. So what we're doing is we're giving a smooth movement of the eye, then look at the sudden change of the eye, and then again a smooth movement of the eye. We're monitoring the eye sizes and positions, and the results are here. So what do we look for in these tests? Well, one of the first things you'll notice is that the test starts here, and the subject started tracking here. There's a normal delay in the time to find the target. That will be reduced if you're impaired. You need these breaks in the eye position relative to the actual target position. Those are eye saccades, and they're normal. People do that. You stay a little bit behind the target, then you catch up, and then a little bit behind the target, you catch up. Now, if you plot instead of position this over time, so we have the time axis here instead of an axis, you'll notice here the eye positions are not in sync with the image position. So how do you quantify that? The first one is that first period that it takes you to catch up, latency. The second, if you look at the eye position in the linear part of the curve and the actual eye position, target position, there's a delay. We call that the phase. And you can also look at the size of the saccades and their speed. So how far do you move and how quickly does it move? So now you have 5 different variables, as opposed to saying, as the doctor says, yeah, smooth pursuit, it's fine. We have 5 independent variables that can quantify that lag. Number of saccades. If you're cognitively impaired, that will increase. Amplitudes of the saccades will increase, but the speed will decrease. The phase increases and the latency increases. So those are all slowdown of brain functions mostly. So our product that we're developing, and it's at the prototype stage right now, but we are very close to starting designing the actual product, is a product to screen for potential safety risk. It'll be non-invasive. So as you will see when I have Nicole up here, you're actually standing 20 centimeters from the actual device. There's no touching between the subject and the device. The tests last approximately 2 minutes, so it's very quick. It doesn't break the workflow. The test outcomes are given to you right on the device in real time. We will have it available as a self-administered kiosk. What we mean by that is that there'll be a box, the subject will just sit in front of it, press start, and everything else will be completely automated. No need for a supervisor or an operator to have it. We'll also have a mobile device that's in the second phase of development, and that one is assumed to be operated by a supervisor or an agent or someone who's coming on site to test you. And we're making sure that we have all the secure network communication to save and protect all the information of data information so that it never gets out in the public. So why did we come here? Because we don't actually have the product now, but we wanted to start to generate some excitement in the industry for this technology. And we wanted to make you aware of it because we think it's exciting and has a lot of prospect. As we develop the product, we're going to be trying to go to 2 or 3 different markets. We need to understand the mining market much better. We need feedback from you, the potential users. Make sure that it fits in your business, in your workflow, in your operations, in the information that you're given and who uses it, and et cetera. And as always, as a startup company, right, we're interested in partners for development, testing, and validation. So now, if you don't mind, I will just show you how easy it is for me to run this with Nicole. So Nicole will sit in the chair. And people, there's only a few of us. So if you guys want to move forward, I can't put this computer on the screen, so if you want to see what's happening. So if people want to move forward to see how the technology works, because we can't just switch screens here. Can you turn that big light off? Absolutely. Thank you. Can I bring the mic? So what you'll see here that Nicole is in the system. She's being monitored in real time. And I will just say, please don't blink. And we will start testing. Keep your eyes open. Her pupil are very small right now. There's too much light in here, right? But you can see that we're monitoring in real time. You can see the blips. The test right now is made for 1 minute. So I'm repeating the test twice to make sure that I have redundancy and reproduce the data set. Okay, Nicole, thank you. Now, send the data to be processed. No, this system is not optimized. It's a prototype, so. It locked up on me. But the window comes in and gives you all the pupil size and the pupil parameters. This is the problem with live demos, right? So now, what we did here was we brought a prototype, and we did not bring the skin that goes on it. I thought maybe, I'm a nerd and I love to look at the technology, so I thought maybe some of you people would like to look at it. So if you have questions, and then we can come and visit the device.
Hi, how you going? So how much do the indication parameters vary from person to person that are healthy and operating at their best?
Parameters vary widely from people to people. So some of the things that we have to take into account is age. I'm a 60-year-old with no matter how much light there is, I have a 3mm pupil, right? You being a younger person would probably have a 6 or 7mm pupil. So it makes a big difference. So you have to accommodate for that. But that data is available in the literature. So we send information based on where you sit in the population group. So you are 2 standard deviation above the standard group for your age. That's not good, right? You're 20% above, that's okay, because that's still normal. That's the way we do the criteria. Then as you build up data on your patients, on your individuals, you can then compare their results to themselves, right? You can start using them as their own baseline, but you start off with population-based data and et cetera, yeah.
Great, thank you very much.
My pleasure. Good.
Well, thank you, Rajan. That was absolutely fascinating. I think that from the demo, we concluded that neither he nor Nicole were at the tequila tasting contest at 8 this morning, and we're all good to go.